I'm going to construct a sequence where I start with some number. Let's say I start with the number a. And then each successive term of the sequence, I'm going to multiply to get each successive term of the sequence, I'm going to multiply the previous term by some fixed non-zero number. And I'm going to call that r. So the next term is going to be a times r. And then the term after that, I'm going to multiply this thing times r. So it's going to be a. If you multiply AR times R, that's going to be AR squared. And then if you were to multiply this term times R, you would get A times R to the third power. And you could keep going on and on and on and on. And this type of sequence, or this type of progression, is called a geometric sequence or progression. Geometric sequence. You start with some first value. Let me circle that in a different color since I already used the green. So you start with some first value, and then to get each successive term, you multiply by this fixed number. And in this case, this fixed number is r. And so we call r our common ratio. Our common ratio. Why is it called a common ratio? Well, take any two successive terms. Take this term and divide this term by this term right over here. AR to the third divided by AR squared. So if you find the ratio between these two things, let me rewrite this in the same colors. So if you took AR to the third power and were to divide it by the term before it, so if you were to divide it by AR squared, what are you going to be left with? Well, A divided by A is 1. R to the third divided by r squared is just going to be r. And this is true if you divide any term by the term before it. Or if you find the ratio between any term and the term before it, it's going to be r. And so that's why it's called a common ratio. And so let's look at some examples of geometric sequences. So if I start with the number 5, so my a is 5, and then each time I'm going to multiply by, I don't know, let's say I multiply by 1/7. So then the next term is going to be 5 over 7. 5 over 7. What's the next term going to be? Well, I'm going to multiply this thing times 1/7. So that's going to be 5/7 times 1/7 is 5/49. So it's going to be 5 over 7 squared, or 49. If I were to multiply this times 1/7, what am I going to get? And I'll just change the notation. I'll just get 5 times, I don't actually know in my head what 7 to the third power is. I guess I could calculate it. 280 plus 63. Let's see, so that would be, 7 times 40 is 280. 7 times 9 is 63. So you're going to get to 343, I believe. Let me see, did I do that right? 7 times 280 plus 63 is 343, and you can just keep going. So this right over here is an example of a geometric sequence. Started with some first value, and each successive value I multiplied by 1/7. 1/7 is the common ratio here. Let me give you another one. Let's say I have this. So let's say I have 3, and then let's say I have 6, and let's say I have 12, then I have 24, then I have 48. Is this a geometric series? And if it is, what is the common ratio here? Well, you could figure out the common ratio by just taking any two successive terms and dividing. Well, first you could try it with two terms. So 12 divided by 6 is 2. So we have to multiply by 2. To go from 12 to 24, you multiplied by 2. To go from 24 to 48, you have to multiply by 2. To go from 3 to 6, we had to multiply by 2. So you had a fixed common ratio. For any of these terms, we multiplied by 2 and then say multiplied by 3. And so we didn't multiply by the same thing. Then it wouldn't be a geometric sequence anymore. So this clearly is a geometric sequence. I forgot to mention that.